Hello and welcome to Empowered Learning. This particular lesson will be on how to derive the graph of inverse tangent by using the graph of tangent as its basis. So to get started here, we see that we have the graph of tangent here to our far left graph for one full period of it. Okay, and if we're trying to find the inverse of a function, then of course we have to know that the function that we're dealing with is 1-to-1. Now, the graph that I have drawn here for one full period of tangent is a 1-to-1 function, but the graph of tangent itself is not 1-to-1. For instance, if we were to keep on with drawing tangent, of course, we would extend this out some. And so here we know that our next vertical asymptote would be at x equals 3 pi over 2, and here at pi would be the next place where we have the x-intercept, and then our graph would go up like this and then come down like that. And so my point here is that if we did the vertical line test, of course, this graph passes with flying colors. Okay. However, if we did the horizontal line test, the graph would not pass, because you see this horizontal line intersects here and here. And we know that in order for a function to be 1-to-1, it has to pass both the vertical and horizontal line test. So just like how we do with the sine function and the cosine function to get the inverse graphs of those, for the tangent we have to do the same thing. We have to restrict the domain of tangent x in order to figure out what its inverse function could be. So here, if we restricted our domain from being in between one vertical asymptote at x equals negative pi over 2 to the other at x equals pi over 2, then we could use this whole graph going from here all the way to here for one full period to represent our 1-to-1 function for tangent, and then we could produce our points for the inverse tangent. And so here, whenever we have a function that's 1-to-1, all we have to do is interchange or flip the x and y coordinates to find the inverse graph. So I'll do the 3 here in the middle first. So we would end up having, instead of negative pi over 4, -1, -1, negative pi over 4, 0, 0, and then 1 pi over 4. Okay. Now for the first and the last, notice that we have vertical asymptotes at x equals negative pi over 2 and x equals pi over 2. If we were to invert or flip a vertical asymptote, that would actually turn into a horizontal asymptote. So how we would express this quote-unquote point would be to say we have a horizontal asymptote at negative pi over 2, and then here we would have another horizontal asymptote at pi over 2. Okay. And so what we can do now is just invert those particular graphs, and we'll invert the graph of tangent x using these points here, and we'll see how the graph looks. So that's what we'll go ahead and do next. All right, so now that we have the Cartesian plane for the tan inverse graph up, we'll go ahead and plot the points and then see how everything turns out looking. So to start off, we will note that we have horizontal asymptotes at now y equals negative pi over 2 and y equals pi over 2. So we'll go ahead and draw those in now. So we'll take our first one here at negative pi over 2. And same thing at pi over 2. Y equals pi over 2 rather. Okay, so now that we have that, we'll go ahead and plot our other 3 points. And so we see here at -1, we have negative pi over 4. So negative pi over 4 is about halfway in between. So that point would be about right here. We have the point 0, 0, and then we have the point 1 pi over 4. So that would be about right here if pi was there. And so following the profile of how this graph would go, you would see that this portion would come like this, connect, and then ride along the vertical asymptote. Okay? And so here this portion would come, connect, and then ride along the vertical asymptote this way. So it looks very similar to tangent of x, just inverted, of course.